I'm Nikki Bray, and we're going to talk about the Kruskal-Wallis Test in Statistics, Chapter 13, Section 5. The Kruskal-Wallis Test is also called the H-test. It can be used to compare 3 or more means. Each sample size has to be greater than 5. With the Kruskal-Wallis test, use the chi-squared distribution to find the critical value, and the formula for the degrees of freedom to look up the critical value in the chi-squared distribution table is k minus 1, and k equals the number of groups. Now that we've went over some basics, we're going to work through an example to help you better understand the Kruskal-Wallis process. In this particular example that I've made up, and there's no research or no real values here, I've just come up with them on my own. An RD wants to find out if there's a difference in the diabetic patient's blood glucose if the patient receives exercise throughout the week. Is there a difference in blood glucose readings at alpha equals 0.05? And here we have the 3 different groups, A, B, and C. A received no exercise throughout the week. B received 15 minutes 3 times weekly of exercise. And C received 60 minutes 3 times weekly of exercise. And here you see the blood glucose readings. So for the solution, first we have to state the hypothesis and identify the claim. The null hypothesis is there is no difference in the patient's blood glucose readings depending on the amount of exercise they receive throughout the week. The alternative hypothesis is there is a difference in the patient's glucose readings depending on the amount of exercise they receive throughout the week. The next step to a Kruskal-Wallis problem is we have to identify the critical value. And the equation for the critical value is k minus 1 gives you the degrees of freedom. And k in this instance in the Kruskal-Wallis test is the number of groups. So 3 minus 3 was the number of groups because we had groups A, B, and C, minus 1 equals 2 degrees of freedom. The critical value using table G, or the chi-squared table, is 5.991. Step 3. We have to compute the test value. The first step in computing the test value for a Kruskal-Wallis problem is you have to arrange the values from lowest to highest and rank them. So I went through here and I'll put all the values that we had in the problem, and I ranked them 1, 2, 3, 4 depending on where they fell and what group they were in. That's important in a Kruskal-Wallis test. And step B to compute the test values is find the sums of the ranks for each group. So A was ranked number 4, 6, 8, 13, and 15 for a total of 46. B was ranked 2, 5, 7, 12, and 14 for a total of 40. C was ranked 1, 3, 9, 10, and 11 for a total of 34. So for step C, in step 3 of finding the critical value, we have to substitute in for the formula to find the H critical value. So our sample size was 15. R1 was 46, that was the sum of rank 1, group A. R2 was the sum of was 40, was the sum of group 2, or group B, and R3 was the sum of group C, which was 34. and then N was equal for all the groups, was 5. So after we plug in the values and use the order of operations, we come up with a critical value of H equals 0.72. So now it's decision time. Since 0.72 is less than the critical value of 5.991, the decision is to not reject the null hypothesis. So now, after we have decided whether to reject or not, we've made our decision, and we have come to the conclusion and the summary that there is not enough evidence to reject the claim that there is no difference in the blood glucose readings of patients depending on the amount of exercise they receive throughout the week. The differences are not significant at alpha equals 0.05. And this concludes an example and a short lesson of the Kruskal-Wallis test.